My good friends, I apologize that I'm only able to write to you in such a time of need. But you see, I've landed myself in a great deal of trouble, and I need your help to get me out. Some parties have seen my less than wholesome activities last week, and they were far from forgiving. Meet me on Monday at 1 p.m. and Thursday at 4 p.m. on Zoom. Thank you. Oh, they're here! Oh, ooh, that's lag. That's lag right there. All right, give me a second. I'll sort. Okay, that's my good friends. What the hell is going on here? I'll give you guys a peek into my debugging efforts, I suppose, while I'm. Yeah. Oh, crap. Okay, everything is going off with this then, huh? Alright, so here, I'll show you my actual screen, and hopefully we can do this the lame way. Do you guys actually see my real screen now, and not my, like, weird virtual shit? Okay,
Yeah.
good. We're gonna do this the lame way. I don't even know what's being used right now. Literally nothing is using anything, but the computer is lagging, so we'll find out later. For now, I'll have to use the peasant solution. Alright, so today we're dealing with linked lists. I'm sure none of you have heard of those before, and that's alright. I'll introduce them in the context of the things we were doing before. So if you remember last tutorial, we were working with these strange things, like resizing arrays for the inventory for the client class, and then we went on to some other stuff and did all that. But the important part is that we were resizing this array, and that's no good, because if you remember, if we look at that code, let me just open this stuff up, and there is also a new GitHub. I'll drop you guys the link in the chat if there is a chat still. Don't quite know because it's not working properly these days. Ooh, no, that chat has disappeared now. Great. Oh no, it's here. Okay, perfect. I'll drop you guys that link. Come on. Oh, perfect. Now where is the bloody chat? Oh, no, it's like, yeah, oh, yeah, you click that and it comes up. Perfect. All right, there you guys go. You've got the link to the GitHub. Now we can clone that as ever. So just git, and then not that at all. I'm clicking the wrong button. Get from version control. Thank you, sir. I appreciate you and your GPU. They're doing great work. I don't believe I have the option to allow you guys to record. I'm sorry. So
Okay.
thank you for your recording. I'll ask you to get in contact with me and send me that when you can, okay? Thanks, man. All right, so here we've got this code, right? And if we go into by, you can see this little block of code here is where we modify the array. And every time that we have to add something or remove something from our array, we have to create a new one. Similar to how in the soy sauce bottle, it has like a certain capacity, and we can have it be at less than its maximum capacity. But as soon as we want to exceed that capacity, we have to create a new one. Like we have to create a new bottle. Similarly, you have to create a new array. And if you have like a half full array, you just have all these empty slots wasting your memory, right? So there has to be a better way. And that's what we're going to go into with linked lists as one of the many solutions to the better way to do that. Now I'll just stop the screen share, start the proper video, go back to my paper. Oh, why is the phone app so hard to use? Stop share, start video. All right, now how do I make myself see myself? That's another great question. I also don't know what I'm on right now. Oh, okay. So here we've got a linked list. Imagine each thing of data. So this could be like a number. Let's just say like this one is 3, this one is 7, this one's 5, this one is, I don't know, some other number. And then these are all linked to each other like this. So what the hell do we mean by link? Well, if you remember back when I talked about passing by reference in the previous tutorials or in class or wherever you might have heard of references, you know that we can store references to objects in Java, right? So these Java references, not Java references, these references in Java can also be used to store to reference an object of the same type within an object. So if I have like a public class I don't know, foo. And then in public class foo, I store a private field, private foo a, and then more stuff, right? Well, here I'm storing a reference to a foo in a foo. Like I'm storing a reference to a class. I'll make it landscape maybe for you guys. I know a portrait video is a big sin, so there we go. Maybe that works better. Okay, so yeah, I've got a public class foo and a private foo as like a member of that class. And then here, I'm able to hold a reference to another one of these things. So this is already kind of the basis of a linked list. I've got a class, like an arbitrary class, and it stores in itself a reference to another class. Does that kind of make sense to people?
Yes.
Yeah, okay, cool. I'll go into it a little bit more because I feel like that explanation is not the clearest I've ever given. So I'll say it again slightly different. So you've got some kind of object, right? And this is like an object of type A. We're just going to call it class A. And this object has all these different kinds of things it can store. It can store like an int for its value. And let's say it can store let's just say an int for its value. That's what we care about. And then also it can store a reference to another object, for instance. So we can make it reference, say, whatever. I'm just going to say it's going to reference another A. So I'm going to say A, another. And what this reference means is that this itself is pointing to another object of type A, which has an int value and then another. Now you might think that this is going to go like an infinite loop, right? Because this one references an A, and then this one references an A, and then that goes on forever, right? Well, if you remember in Java, when we have a reference type, we can also have it null. So here we can make this one go to A, int value, A, null. And now suddenly this is the end. So now we've got this kind of structure where here this one references an A, this one references another A, and then we can end this whenever we want by just making one of them reference a null. So do you guys kind of see how this is turning into a bit of a linked
Yes.
list of A's, right? So yeah, the confusing part for me when I was learning this was the fact that A is a class and A is an object, because a class is an object. A equals class equals object. These are instances of A. Yeah, these are all instances of A here, and A is a class and an object. So A holds a reference to another A, which holds a reference to another A, and then this one holds reference to null. And that's how we kind of construct this list. Now, can anybody kind of guess how theoretically we could move on to another link, how we can add another link to this list?
Well, by putting a reference to like a null, replacing replacing the reference to the last A.
Yeah, exactly. You can change the null to something else. So here we can have another one. And then this could link to another A, which has an int value and a null. So that is a lot easier to do than to have an array. Like imagine the array is like the bottle of soy sauce. We have this array and then we have to fill it up past the maximum point. So we have to get another larger one and use that instead. That takes a lot more effort than to just change this null to reference another object. And that's kind of the core advantage of the linked list. It's a lot faster to do that. Like it's a lot faster to change just this one little thing than to completely rewrite a brand new array. For example, if I had an array, let's consider this to be an array. Like it's a thing it's got 4 slots or 3 slots, right? And in these slots, it can have ints. So here it's got like the number 1, the number 2, the number 3. And now suddenly I want to add another thing to this array. Well, when I'm drawing, I can just add another box. But in programming, I can't just add another box. These are just a set amount of slots. They're permanently there. So what I have to do is I have to draw a whole nother one with an additional slot. I've got to copy over the previous data, which takes a lot of time. And then I've got to add my new data. And then I've got to delete this one. So that takes a really long time. Whereas if I have a linked list, I can, in Swarm of Hornets for the assignment, you have to use an array, right? My understanding of the assignment is that you have to use an array, except I'll say that the kind of methods that you implement in Swarm of Hornets are exactly the kind of methods that a linked list has. So I think that there's probably a way that you could do to use a linked list, which would be better, faster, easier, and you could just use a method to convert it to an array, but don't quote me on that. I think if you're resourceful though, you could totally find a way to use a linked list for that. And that is kind of the point of it. The point of the stat part of the assignment is, well, when I say assignment, I mean the one with the bees. the point of that part of the assignment is to actually introduce you guys to the linked list. It might not be direct, but it's kind of like an indirect way to get you guys to this conclusion. Anyways, so we had the array, we resized it over there. It didn't work very well. If we resize the array over here, or instead of resize array, we have a linked list. So we have a 1, and that makes a point to a 2. And that makes a point to a 3. All we have to do now to add a 4 is just add another one. And it's kind of the same for removing stuff from the start or the end of the list. So if I want to remove the 1, I can just say, oh, we don't have a 1. We're just going to start at 2. But what if I want to remove something in the middle of the list, like the 3? Does anybody have any ideas how I could do that? Do you mean we can change the references from, they're like, you just take this arrow that points to 2 and you just change it to point to 4?
Or put like 3 to null.
Yeah, you can make 3 point to null and you can make 2 point to 4. And then suddenly you've edited the list. And that's actually the hardest thing in all of the linked lists, is just to do that step. That's all, like that's how you remove something from a linked list. But that is usually what people struggle with. Like when we did the assignment for this and when I was in Comp 250, the thing nobody was able to like do on the first try was to make the removal step work properly. Because it's a little bit tricky. You just juggle a lot of stuff. Like you have to say that the so the pointer of 2, which I call like the reference pointer of 2 goes to 4. Pointer of 3 goes null. And then that's actually literally it. But it's kind of hard to like juggle it sometimes. And you'll see when you're writing the code, it just feels confusing. It's actually really, really easy. And especially when you have it like this. But when you're just learning it from like a class context and you never see how it's applied, it can be a little bit tricky, but it is just as simple as that. All right, so we've gotten through that idea of the linked list, and I think that's relatively kind of it. So does anybody have any questions about the linked list? Any other further detail you might want in the explanation, or is that kind of make sense to everyone?
Can you go back to the A object?
Yes, sure. Okay, I'll do a better job defining the A object. And the A is usually called like a list node, stuff like that. So A is an object, and here's
Yeah, but is it a class or an object? Like, I don't know.
well, here, if we put it in codes, it can be public class A, right? And A has a private A reference. And this is just Java. Private A reference, and it's got like an int value. Right, and then here we've got, let's say, a public A constructor, which takes a int val, a ref, and then here we could say, you know, a, or this dot ref, yeah, reference equals ref, and value equals val. There, that's kind of the pseudocode of it. That's like the, or not pseudocode, that is literally the Java code of the most basic kind of A. And then actually we'll just nuke the private modifier to make it even easier. So this is how you can imagine this object to be defined. It's going to be a public class A, which has a reference. I'm not even going to make them private because I don't want to write getters and setters on paper. So it's got an A, which it holds as a reference to another A, and it's got a value, right? And in each instance of an A, when we create them, we can say like, you know, A1 equals new A, value will be 1, and then reference will be null. And now we can say B2 equals new B1 comma 1, or I guess 2 comma 1. Now, can anybody kind of guess what this would actually be doing in the like list drawing? Like when I drew the list, how would you guys express it in that context? Oh, it's not a B, it's an A.
Like array, we're using arrays.deep to string, or
Mistake there. It's supposed to be an A. So this thing is A. I'll even write that neater. Sorry, I'm not used to writing on a 2 equals new A. There. So ignore that line. So you've got these 2 lines of code. Can you guys kind of maybe interpret how that would look in the chain of links kind of drawing?
Well, it'll be like first element will be like a list, and second element a list, etc. Basically, just elements of lists, or
They're not necessarily a list. I can draw it here for you guys, and maybe it'll be clear. So we've
That's
got 1, which is going to be an A1, and it's going to have a value of 1 and a reference of null. Right? Then we've got A2, which has a value of 2 and a reference of 1. And that makes it point to this one. Does that kind of make sense? So this one is A1 has not a reference to anything, so no arrow pointing anywhere. A2 has its reference as 1, because if you see by the code, you pass the reference here and then it gets saved in the fields. So this one holds a reference to this one. And now, if you start on A2, right? So if you've got 2 dot reference, that is equal to 1. And now this property here is very useful, because now if we've got a chain of these, let's say there's also an A3, which points to 2. Then what we can do is we can start on 3 and we can say 3 dot, and let's say there's a method that gets the pointer. So I'm going to call it get ref is equal to 2, and 2 dot get ref is equal to 1. So you can kind of work your way back through the list. If you start at this node, you can work your way over to the first one. Does that make sense to everyone?
Yeah.
Okay, cool. So now if we know we can like traverse it, so we start on this node and we can move to the next node, the next node, the next node, and we know that we can add them, we can remove them, and it's all really easy to do all that stuff. We can kind of have the basis for the concept of the data structure. And seeing as this computer appears to have turned on at this point, I can try to put that into code. Yeah, perfect. We had made good time there. So I'll try to start up Zoom on this computer, and we're going to see if it actually works. And if it does, that'll be great. And if it doesn't, oh no. All right, so that's all starting up. Starting that, starting so many different things. Hopefully will work shortly. Hopefully. Okay, failed to open virtual machine. That's just great. Okay, no virtual machine for us, but we'll do a real machine instead today. Okay, so where is my IDE? Okay, cool. I'll try to switch to the Zoom meeting on my computer now, and we can actually look at some code, and that might make it a little bit easier. Monday tutorial start. All right. Okay. Ooh, double. Yeah. Just gonna... Now you guys should be able. Ooh, oh. Okay. Sorry, I needed to mute my phone there. You guys should now be able to hear me, and it should not be echoing. And you should see a video broadcast. Oh wait, no, you shouldn't, because I haven't started that yet. Oopsies. All right, let's fix that first. Webcam, video capture device. Yeah. Filters, virtual cam, start. Okay, now you guys should see my webcam. And you guys should be able to see my monitor if I screen share you. Screen 3. Okay, do you guys see a big monitor with lots of very small text? Sorry about the display scaling there. Oh, don't do that. I want to have them in like one recording, please, so I can switch this together. So if it's possible, no problem. What I can do for you is I have a Google Drive like G Suite, so you can upload with unlimited. Like you can upload to my Google Drive, not to yours, and then it'll have unlimited space. We'll have no problems. Yeah, 100%. We can sort that out when there's time. And sorry to the rest of us who have to deal with my technical difficulties here. But hopefully that's all behind us now, and you can see my screen share, and we can actually go into the code. I'll send you guys the GitHub link to the chat as usual. Let's see, where's this open? Tutorial 4. Perfect. And I'll get you that link right away. Can you open Git from Eclipse? Yeah, you can do it the Eclipse way or the IntelliJ way. I'll be using IntelliJ just because that's the one I prefer. But I'll show you guys an Eclipse. Why not? Let's see, it'll probably take 10 years to open, but yeah. Launch. Come on. It likes to take its time, this IDE. It really thinks about it. All right, it's open, but obviously it opened on the wrong screen. There we go. If you want to put it into Eclipse, you just do import projects from Git with smart import, clone URI, paste the link, and press finish. And then you've got the code on Eclipse. Tutorial 4. We're going to be working in the list of links class. Hopefully everybody sees that. Oh, I'm blurry again. Bloody camera. Never trust a Sony. All right, so how is the project cloning going for everyone? Is that good? Is everybody on their way to being cloned, or should I wait a bit for you guys to get that ready? I'll start a poll for that. Oh, and did I forget to drop the link in the chat? I probably remembered. Yeah, I forgot. Of course I did. There we go. I dropped it again in the chat. There you go, and you can clone that. All right. While we wait for everybody to clone, I'll introduce you guys to where we are in the project. So here we'll be working in list of links, and you'll see some weirdness here, a lot of weirdness. You'll see a ton of empty methods, but it's okay. They're all really easy to implement. Most of them are getters and setters. And you'll see this weird E thing, which I'll explain to you guys in a second. But first, can anybody guess what this weird triangle bracket E thing is going on right here? I'll see if I can make the font bigger for us while we wait. One of you guys says generic. You are right. You are quite advanced for that. We have not seen that yet, and we won't see that for a while in the class. But I think it's a really easy concept. So I'll try to introduce it to you guys now. It's not an enum. It is a generic. And I just want to find my font size option in IntelliJ so I can make it big for everyone. Settings. OK, perfect. Size 12. Use custom font. OK. We want mono, size 20. Oh, that literally changed the font everywhere but where I needed it to. What the hell? Nope. Editor. Okay, perfect. So yeah, you guys can see the font more clearly, right? You can see the bigger text. Is that clear for everyone?
Yeah, thanks.
Okay, awesome. So this E is a generic. What that means is that when I create the object, I can actually tell it what class E is going to be from outside. So if I look at my client class, you can notice that I've redone the array-related methods. And instead of using an array, I'm using a list of links with then a product in these triangle brackets. So what this means is that everywhere where there's an E, in this situation, that actually means product. And whenever somebody creates an element of this class, they can actually specify what E is going to be. So I can be like public static void main string args. And here I can say, new or list of links, list equals new list of links. And you can see that it gives me this yellow highlighting. It doesn't let me do this. That's because it's a generic. So here I can put list of links string. And now everywhere where there's an E in my code, what it actually means is it's a string. So E just means it's a placeholder. It can be any kind of object. So I can put a string. I can put here a integer. I can put here a I don't know, a scene from JavaFX. That's not even a thing here. I can put a, I don't know, what's a really weird object? I could put like a vector. Yeah. Like I can put all kinds of weird things in here. The point of that is that I can put whatever kind of object I want into this type here, and then the E is just going to be replaced by that. And it's just a small detail. It's not something you have to know for a lot of the time, but you will have to know it later on in this course. And it's just a really easy concept I thought I'd introduce now. But let's get to the important part. So here we've got two different classes. We've got a list of links and we've got a list node. And we're going to start with the list node. So can anybody kind of guess what fields we should put into the list node?
Well, like value and reference.
Yeah, that's exactly the same thing we were doing on paper. So do you want to kind of maybe go into why we would want a value and reference and how we could do that?
Well, it's because like each like element of the list, we could say, has like a, or each element of the list is like an object with one integer whatsoever value, and then a pointer that points to like the next one. You know.
Yeah, exactly. You've got one value you're storing and one reference to another node you're storing. So how would, if you guys can jump in the chat, how would you put the fields so that we can have the value and the pointer in the fields of this object? Private element. And what type is element? Sorry. Like that, if I paste that into my code, yeah, so it would be, you could say private E element, yeah. And that could be the, like the actual data that's stored inside the list node. And E, remember, can be anything. E is just a placeholder. It's literally like, you know, Control F, you find and you replace. So E can just be Control F to anything when you create the object. So it can be a string. It can be literally whatever you want. E just means you don't care what it is. And then what else would we need to store in here? Yeah, a list node E, that's pretty smart. You guys can actually tell that by saying, by looking at the different kind of methods I've got here. I've got a setter, which takes a list node E as data. And so I could just say private list node E. And it's not called data, it's called reference. Okay, so now that I've done this, it probably seems confusing. So like how we don't have an infinite loop because we have a list node with a list node inside a list node. So that's kind of strange, right? So the reason that we can have a list node inside a list node is that it doesn't have to contain another list node. It can also be null. Well, we could also make it be circular anyways. Point is, it doesn't create like any kind of infinite loop situation. There's no recursion here because it's just storing a reference to another object of the same type. Should we have size too? Well, size is something we are considering in the actual list class. Right now, we're only worrying about the node, like the thing the list is made of. Because remember, we've got a chain of these elements. And the list is nothing but a chain of the elements. So why do we need to make nested classes? Well, because think about the way the list works. If I have the paper up here, will that focus? No, of course it won't focus. The camera is bad today. So the list is made up of nodes, right? And when we think about a node, when we think about object-oriented programming, when we have an object which has the same kind of properties as another object, it needs to be have lots of instances, we would create an object for that, right? So that's like if we look back to the earlier sessions, we remember that the reason we create an object is that we have things that can have similar properties to each other and just have different values in their fields. So that's why we have the nodes as objects. Like that's why we have them in their own classes. And then we have a list node class, or we have like a list class that is outside of the list node class because we want to have some properties of the list that are not shared by these specific nodes. For example, the list node has to be able to, list node has to be able to point to another node. Whereas the list has to, calculate its size. It has to iterate through the nodes. Like, you have to be able to do a for loop with it. There's all kinds of stuff a list has to do that a node does not have to do. So that's where there's two different classes. Hopefully that makes sense.
Yeah, just sir.
Yeah, sure.
Like in private class list node, it says like an error, and it says like illegal modifier for the class list node. Only public, extract, and final are permitted.
Yeah, that's just because I put an extra bracket and I forgot to notice that. If you just delete the bracket that's directly above it, it'll be fine. It should be inside of the class list of links. So like it should look like it does on my screen now, where you have list of links, and then inside of list of links you have a private class list node, because that class is only useful inside of list node or list of links. I don't know if we've seen inner classes yet in this course, but the function of it is that you have an outer class list of links, right? And it has its use outside of it. But the class list node is literally useless in any context except for inside this list. Like you could never come up with a situation where you need to have a list node outside of the list, right? Like it's totally useless unless you're in the list node. Why do we need to make nested classes? So we use nested classes like C++ struts. Kind of, yeah, like it's a similar concept, but I want to avoid the C++ comparisons just because most people are not familiar with it. So it might just make people more confused. For the sake of the course, we use a nested class because this class here has absolutely no use outside of this class here. Like the only time we'll ever need to use a list node is inside of a linked list. And that's why we have it inside. So again, it holds an element and it holds a reference to another element. And the way it holds a reference is it just holds a list node inside. And just hopefully that's really clear. I'm going to hammer it home a lot because I know it's kind of weird to think that it holds a reference like that, but it does. And then when you create it, so can anybody think of how you would create a new list node, like with the constructor? Which fields do we set and how do we set our reference? How do we set our element? What goes on here in the constructor?
A list of nodes?
Sorry, can you repeat?
Like a list of nodes, maybe?
You could maybe have a list of nodes, but I don't think that's what we're going for in the constructor for list node. Remember, we're only looking at the specific list node. And actually, element is not maybe a misleading term. This is the stored data. I would refer to it. So we have a list node, and it's got the data it stores. So this is the payload of the list node, what it is storing. And this is a reference to another list node. So when we instantiate it, what we can do is we can set the stored data to be whatever's passed to it. And that could be our first step. So we can just say stored data equals data. And does that make sense to everybody? You just create one and you set the data that it will contain to be the data that's passed to it. Like you create one and you have data in it. It's just a wrapper class. It's like the integer class wrapper class. It's like any other wrapper class. You just store data. But then then we have to deal with the reference that it's storing. So when we create a node and there's no other nodes in the system, there's lots of different ways we can handle the reference that the node is storing. But a simple solution could be that unless we're otherwise told, we can just make the reference null. And hopefully it makes sense to why for all of you guys, why I did it like this. And if you guys are following along, that's hopefully you understand why I did the same. I see somebody turn on their mic. You're welcome to ask a question. Oh, or not. Okay, well.
Why is the reference none? Like,
The reference is null because we don't have a reference, like we never passed it. So this is just one node by itself. We're not actually thinking about the list right now. We're only thinking about just this one node of the list. So on the paper analogy, I don't know, can I start video from this one too? Oh, I can start video from my phone. So you guys should see the paper now as well, right? Yeah.
yeah.
Hopefully. Okay. So when we create just a node by itself, it doesn't have a reference to anything. We just have some data. And then it has, this room, which it can use to point to something potentially, but it doesn't point to anything right now because there's nothing else, there's no other nodes in the system for it to point to. But then if we create a second one, then this one can point to over here. Does that kind of make sense? Like when we first create it, it doesn't point to anything. It's only going to start pointing to things when there's more things in the loop. And that is something we have to deal with in our list of links class, not in our list node class. Does that make sense?
Yes.
Okay, awesome. So I'll switch that one off. Okay, so yeah, we've got the data stored and we started with null. And now we just need to create some really simple methods. You can notice that these are all actually getters and setters. So here we can just say, what is it? Reference equals data. Here we can just say return reference. Like these are all really simple. Can anybody fill it, like send to the chat how you would do get data and set data? It's like really easy. You can just, yeah.
Well, return data and return data and data equals data.
Yeah, of course. It's just return store data, and here it's this dot store data equals data. Really simple. And we're done our list node class. It's a really, really simple class. I'd like to just accentuate the fact that this class is really just really easy. All you do is you store a reference to a node and this. It doesn't have any logic. That's the thing about it. All the logic happens in here. And this is the hard part. So how do you think you guys would handle the list of links constructor and the fields and stuff? So I guess it's a big question. I'll start you guys off with, can anybody start by giving me what fields I should put into the list of links class and explaining why? Store data. Well, okay, store data, no, and I'll explain why. Remember, we're using the list node to store data. Like we don't store anything in the list. We just store nodes in the list. So the node stores the data. The list stores the nodes. If we look at the paper, we can say that this whole thing is the list. Just have to turn on my, wrong phone. I'll have to turn on my video again. So here, you guys could maybe see, do you see the video I'm streaming from my phone?
Yep.
All right. So we've got this list here, and it's got data, and it's all inside of a list. So we don't store data in the list. We store these nodes in the list. Does that make sense a bit? Just because somebody said stored data. Hopefully that makes it clear why stored data is not in the list object. So the start and end of the list. We could do the start and end of the list, but let's think about how we would traverse a list. How about before we think about the fields, tell me, how would you, when you have a list node, let's say you have one list node which has like a chain of list nodes after it. How would you get to the last one?
It's like next and up to the last one. I don't know.
How do you know that it's the last one when you you go next? How do you know you?
Because the last
When reference is null.
it's null.
Yeah. So you know the last one is where it's null. All right. So is there any way where we can anything we can do where we can store the minimal amount of things in list of links and still be able to access all the elements? How do you think we could store? This is a singly linked list, so we only go one way. Remember, the list nodes only store the reference to the next one. They don't store the previous one. So how do you think we can minimally store data to enable us to access every element, but to save on memory, like to save on the amount of things we have to put in our fields? Always add to first node. Yeah. Okay. Somebody says private list node next. Yeah, you could call there a private list node next, and that kind of gets to the like a little bit of the point. But really, the only field that you need to make a linked list work is just what we call the head. It's the first node of the list. So if you again look at the paper example, which I will pull up on this phone video again, you've got this list here, and it's got these nodes. And then you can make it really long, right? You can make it go forever and ever and ever and ever. But as long as you have this first element, as long as you store this first element, you can always move along the chain. So as long as you have the head, you can always get to the next ones. If you have some node, am I not showing you guys the right part? Sorry, I didn't have a video feed of my phone, so I couldn't see. So as long as you have the head, you can always get to the next elements. So the only thing you really need to save is the head. Because once you have the head, you can get all the other ones. So can anybody put in Java code how you would put that idea into code?
It's like private list node node maybe.
Yeah, you could do that. You can definitely store a private list node as a field. So here we could call it, I'm going to call it head because that's the convention you'll see in class. List node e head. And now it's got the head of the list. And remember, once we have the one element, we can get to all the rest of the elements. So we've got this big list, but the only element we actually need to store is the head of the list. And then we can just iterate through to get to all the other ones. And hopefully that's clear. If anybody finds that topic confusing, I am happy to go over it once again. I know it is a little bit of a complicated topic. So please, if you find it confusing, let me know. I will double down on all those ideas and let you guys know. But otherwise, I'll move on to the getters and setters for now. Can anybody fill in the get first method? Actually, you know what? Maybe just fill in whatever methods you can. If you guys can think of how to fill in a method, why don't you put it in the chat, and then we'll see if it's proper. All of the methods are blank, and a lot of them are just really simple. And then there's some complicated ones too. But let's try the simple ones first. You guys can try filling them in. I would say get first. How would you guys fill that one in?
Head dot get data, I think.
Well, we're actually trying to get the node itself. This is like a helper method.
Return head.
yeah, it's just really that simple. You just say return head. And actually, you were right that it is kind of weird that we're returning the list node. I think I just made that typo, so it should actually just be return head.data. There. So that is a decent way to do it, and then that's get first. So it's really simple. The first one is easy. So how would you guys get last? Like, how would you guys get the data from the last element of the linked list?
While loop.
Traverse to last node. Okay, so why don't you guys try, everybody on their computer, try to write out the loop to get you to the last element of the list. Remember, I'll show you guys on the video feed here again on the phone. The way that you traverse the list is you start at head. You always start at head. So we're going to call this one, like this little box, head. You start here. And then this one has a link to another one. This one has a link to another one. This one has a link to another one, until it's eventually a link to null. And then your destination is here. So how can you get from the start to the end is the question. And putting that into code. I'll give you guys a bit of time to write the code for that, and then we'll see how that goes. And then, yeah. Do you guys still want to see the paper feed, or should I put that phone down and do other things? Okay, I'll assume that you guys have fully seen this. And now I'll go into the thing here. So I'll start kind of giving you guys a few hints while we're here. So it'll probably be a while loop. And then can anybody guess what the while condition might be? And if you're writing your own thing, by all means, you don't have to do this. You can do this your own way, and then we can see if that works after. So while head.reference is not null. Yeah, you can do while head.reference is not null. But if we do that, well, let's try it. So let's say head.reference is not null. And then what can we do?
Well, we have to like use another variable, I think.
Yeah, you're right. Because here, what we could do is we could say head equals head dot next. And then here we could say return head, right? Or return head dot data. Now there's going to be one problem, right? I think it'll work. But what it's going to do is it's going to delete the rest of our list. Because see, when we say head equals head dot next, what we're doing, if we look at the phone here, is we're saying the one that we identified as head, the start point, will actually shift over. So then this one will become the head. And then this one will become the head. And remember, we always start at the head of the list. Like, we can't go back. We can only go forwards. So once we iterate there, then destination will become the head. And suddenly, you've just got a list of size 1 rather than a full list. So we can't say, well, head.reference is not null. We actually have to create like a temporary variable that we can use. So what we can do is we can say like, maybe list node current equals head. And then that creates a temporary variable. And then we can say, while current.reference is not null, current equals current.next. Does that kind of make sense? And here we can then say return current.storedData. Does that kind of make sense to everybody? Why we did that and how we did that?
Yeah, thanks.
Okay, cool. Well, hopefully I'll explain it once again. I'll just go through every line and explain what we're doing and why. So here we're creating a temporary variable. And the reason we create a temporary variable is we don't want to move our head. So here, create a temp variable because we always start at head. And then here, iterate through until there is no more reference to get to. And then here, well, same as above. And then here we say return the data from this, return the data from this last one. Shouldn't we use this dot head? Well, the point of the this keyword is it's not only necessary if you have a second variable here called head. So if I had a local variable here called head, I would have to use this. But unless I have a local variable of the same name, you'll see that it points to the field. And in IntelliJ, you can actually tell because when a letter is purple, that means it's a field. So that means that it's referring to the field head. Whereas if it's not purple, if it's white and it has an underline, that means it's a local variable. Does that make sense? Okay, cool. So that's how you get the last element. Now, there's a lot of other methods here, and we don't have a lot of time because of all the technical difficulties that were happening earlier. So we'll probably do the rest of this kind of content next tutorial, and I'll try to make it a little bit more, not a technical disaster next tutorial. But I'll do one little method here that is just the basic of the linked list before we go, which is add. So how do you guys think we can add an element? And I'll give you a hint. We work with this code to add an element. Can anybody make a guess?
Get like the last element, and then we create a new node, and like the get last will like point. I mean, the reference of get last will like point to the new one. See what I mean?
Yeah, that's awesome. That's precisely what we need to do. So here, this code will get the last element, and in fact, let's just call it. That's why I had it as a list node. Okay, so I'm gonna excuse me for a second while I make a private helper method. Let's return. Okay, so now node. So we get the last node. List node. Well, actually, we'll say get last node dot reference equals new list node. Now that's like a really simple one line of code, and hopefully you guys can understand. It basically reads like English. You literally get the last node, and that's the one where the reference is null, and then you set its reference to be a new list node. Does that make sense to everyone? Any questions? Feel free to drop them in the chat. I'll be happy to answer. Sorry, I went really fast on this one. It's just because I'm running out of time, and I want to give you guys some kind of useful code before you're gone here. And then if you want to get an element from an index, well, what you can do is I'll let you guys implement that one on your own time, but then and I'll do it next tutorial as well. Use a while loop counter, maybe. To get the size, you could count how many times you had to go get last. I'm just gonna put these comments in here to like let you guys know the idea of how to do these things. And if you want,
I think
you could.
forgot an E
Sorry?
for, I think you forgot an E for like the add method. It's like new list node of E data. I think you forgot E.
Oh, that's a good catch. But actually, since here we already specify that the list node will be of type E, and since the data that I'm putting in is of type E, it actually works. So get last node, right? That will return a list node of E, right? Do you see that?
Oh, okay, I see.
And remember how I said earlier in the last tutorial that in Java, the thing on the left is the more specific thing, and the thing on the right is the less specific thing.
Okay.
So we already know that it's implicitly going to be of type of E because the slot for the variable is for type E, and the data I'm putting in is of type E. Does that kind of make sense?
Yeah.
But yeah,
okay.
I could also do this, but it wouldn't be necessary. You can see IntelliJ makes it gray, and that shows that it's like a redundant declaration. And then yeah, get from an index, we can sort of loop with the counter. Is empty, we can just say return head equals null. Just if head is null, return true. If head is not null, return false. And is this enough to make it be able to compile? No, not quite. I'll have to, it's gonna return 0. I'm just making this really work basically so I can show you it running. I think it'll still work with Cartel now. So this is, we only implemented like a small number of methods, and what's wrong here? Oh, I forgot to close the outer class. Okay, so sorry about the quickness of that part. I'm sorry if you guys couldn't follow along. You're welcome to come to the tutorial.
What did you put
Next.
for size? Like The
Sorry,
code,
can you repeat?
like the code for the size method. The size.
For which method?
Size.
Oh, I just didn't do it. I just put return 0 so that it would compile. But we will fix it, and we will understand what we did wrong or what I did wrong next time, as well as implementing all of the rest of the methods. Sorry about the kind of weird nature of today's session. The technical difficulties did definitely set back the schedule for it. So I was only able to explain some of the concept. But let's take the win where we can and say that since we have the concept introduced, and I've got these comments in the code here, what we can do is if you guys want to try working on it over the next few days and implementing these methods, I can show you how I would do it in the Thursday session. And then that could be a decent time. And I'll probably cover the stuff from the start of today's session on Thursday as well, just because of the whole mess of the technical difficulties there. All right, thank you guys for coming and bearing with me through all that nonsense and the computer crashing and everything. It's been a fun time. And yeah, by all means, go ahead. Yep, 100%. There you go. There's my email, and thank you for recording.